All right, so I am continuing to explore interesting languages. I'm on Julia. I did Julia last week, and I will continue to explore language until I get bored of it and I want to try a new language out. So I'm going to stick with Julia right now, and I'm going to continue my journey to understand more about it. And in order to do that, I can go ahead and share my screen here. Let's go ahead and do that. Here we go. And all right, so I'm going to go back to GitHub again, and I'm going to go to Julia. Let's get in here and play around. And let's see here, Julia. Here we go, Julia getting started. And so what I did last week was just basically got it working, downloaded and added things to a path. And I'm also going to try out Julia from an interactive prompt. I do all these things that are kind of the basics. And I was able to create a binary. Well, I at least looked into this. And then the ideas for next week would be performance testing versus Python and getting more into creating binary. I think I got stuck there. So unlike Rust, where like the binary is just trivial, it's more complicated with Julia. So that is definitely not a plus in my book so far. But I'm willing to keep going here and to learn more. So I'm going to go to Julia, getting started, and let's go to the book I was using, which is, let's see here. Yeah, here we go. We're at the Julia book, and let's go back to the documentation. So if I go to the manual, we already went through some of the getting started, which I was able to learn some things. And so I guess maybe the next thing to do here would be to play around more with just the basic language and just maybe stay with that, since that seems like what they want us to cover in the guide here. And I'll go ahead and open a new terminal. And I guess always it's a good idea to see, can I reproduce what I did the week before? Like, can I even run Julia, right? There's probably a good place. Okay, good. So we have Julia. The interpreter appears to be working, which is nice. And if I refresh myself, I say which Julia, yeah, we see here it's inside of the workspaces. And I'm going to go here and double check that everything looks to be correct. I mean, maybe I'll play around with this for a second. Let's keep the interpreter running. So let's go Julia. There we go. So we can see that we can do Unicode, which is kind of cool. And allowed variable names. So variable names must begin with letters A or AZ underscore or a subset of Unicode. Okay, that looks good. So I think I know enough about variables, integers, and floating points. Let's see what kind of integers and floating points they have. They have int8. They have uint 128, largest value, perfect. That looks good. And here we go. Power. These all look good. So in this case, nan times false. When used in multiplication, false acts as a strong 0. Okay, let's try that out. That's kind of cool. So here we go. We saw that. That's neat. Vectorized dot operators. So for every binary operation, there's a corresponding dot. So let's see if we can do something here. So chaining comparisons, unlike most languages with the notable exception of Python, comparisons can be arbitrarily chained. Well, that is cool. So if you go through here and we try that out, I mean, that is interesting. I mean, I could see how this could really be handy in building like ad hoc scientific computing scenarios where you're I don't know, doing some kind of like, procedural scientific equation, and you are having a bunch of variables that get built up, and then you wanted to do some kind of analysis. I can see how that could be pretty cool. So chain comparisons is convenient, again, yeah, with numerical code, and you can see how that would work. Julia provides comprehensive collection of mathematical functions, so I like that. That's pretty neat. These functions can be applied in a vectorized fashion to arrays. So that is actually, I think, a plus over Python here, because in the case of Python, in order to do vectorized programming, you have to use a third-party library, pandas or NumPy, and you have an inconsistent syntax between these three different systems, NumPy, pandas, or the core Python language. And even worse, that if you're using big data, you're not going to use any of those three. You're going to use something like Spark or some other, big data language. So this is actually very interesting that this is built into the language here, vectorized mathematical operations. I like this. There we go. Here's some of them: round, seal, trunk, division. Very interesting. And then we also have complex and rational numbers here. So that's useful. Strings. Yeah, let's maybe play around with strings a little bit here. So let's see what you can do. A char value represents a single character. It's just a 32-bit primitive type. So here we go. This would be something we can play around with. So it is really nice here that that this interactive interpreter allows us to play around with things. And if we do this, you can convert an integer back to a char easily. There we go. We can convert that back. String basics. A basic string would be this. So again, I like it that we have an interactive interpreter here. This is a long string, so you put a backslash in there. That's useful. I would say strings are probably one of the things that are one of the most important things to play around with a language to begin with, in my opinion. And we can slice things, so that's nice. So we can go through here, go into the strings and slice it up, make a substring. That looks pretty intuitive, right? You just say I want from 1 to 4, and it in this case, unlike Python, it isn't zero indexed. They probably say that, right? Or maybe they don't. But basically, the index is at 1, right? So you don't have to worry about 0. And there's other functions like chop, chomp, or strip, which return a substring. And what else can we do here? So you can also slice things as well. So if we go through here, and we want to slice a piece off, we can get the first piece. Okay, well, that's useful. And what else can we do with strings here? You can do substrings. So this is very, very similar to Python, in fact, right? This is a classic kind of Python type thing, is to slice a piece. And blank lines are spaces. So I see. You can do a for loop on these. It's important to be aware of potentially dangerous situations, such as concatenation of invalid UTF-8 strings, like this. I see. You can collect things. It also provides a asterisk for string concatenation. Okay, this is interesting. I see. So you can just basically say, oh, I don't know what that does. That blew up on me. Greets whom? Hello world. What's? Oh, did I I have no clue what this does. Well, this may be a surprising choice to use over language. This has precedence in mathematics. Okay, I don't know what that does. It didn't work, so I didn't learn that part of Julia. But let's go through here. Greet not defined. Well, how do we define greet? Is it that I didn't define the greet? Oh, here we go, greet. Ah, I see. Here's what was missing. I didn't define those variables. So let's do this. We'll say greet is there, and we'll go to whom will be world. I see. And now if I go back, does it have up arrow? It does. There we go. Hello world. So basically, this is a concatenation um, operator. I see. That makes sense. And then if I do the one above, there you go. Hello world. This is the exclamation. I'm sorry. The dollar sign would refer to the variable, and then you could also basically create a phrase essentially by referring to the variables with a dollar sign. So that's pretty useful. Interpolation, constructing strings using concatenation can become cumbersome. Yeah, I don't like to concatenate strings. I would prefer to use some kind of templating. In this case, we say the shortest completion after the dollar sign is taken as the expression. So here to say 1.2 is there, and it says both concatenation and string interpolation can convert objects into string form. Here we go. I'm going to say V. There we go. And I'm going to say I have this much money in my account. And I'm going to go here. And then I'm going to go through it and do a string. And so if I do a string here, you can also do triple quoted as well. So there are some strong similarities here with Python. I can see the triple quote. That's definitely probably inspired by Python. This is very common to, I would say, Swift. I think looks a little bit like this, and you can strip things. So this is common, right? If you have something that prints out weird, you can always strip it out. Common operations, so you can compare strings. Well, that's interesting. Using this, so I guess this would compare the length of the strings. Oh, I see. Is this less than that? What does that mean, actually? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5. So is it alphabetically comparing? So I guess it has a comparison built into it, which is kind of interesting. So I guess it figures it determines the correct way to compare, and so it's comparing, I guess, alphabetically potentially. This is less than this. Using standard comparison operators. Hello world is not equal to goodbye world. That's true. That doesn't work. And then if we do this, that's true. You can search for the index of a particular character using find first and find last functions. Here we go. There we go. Find first, find last, and it's useful. You can also use recursion function to check if a substring is found. Oh, okay. I like that. Occurs in. That doesn't. That caught me off guard for a second. Like occurs in. What do you mean by occurs? Oh, I see. Oh, occurs in. Literally occurs in. Does the word occurs? Is it in hello world? And it is. And so if I tried, what if we do a like not a full word? What if we say okay? So what if we say that is no? It doesn't appear. So basically, any substring that appears in the string, including just a character. What about a space? We know a space appears. What happens if I do that? It's true. A space appears. Does a comma appear? Yeah. What about a comma space? Does that occur? Okay, so that's a useful thing to know. I could see this being something you'd want to use quite a bit. And the last shows you can look for a character. Well, so this is all what I was figuring out. So you can do repeat. Oh, repeat and join. That's pretty cool. So we can go through here. So there's some nice string functions here inside of Julia that are very high level, and also join here, which we can go through, and we can do join apples, bananas, and pineapples. So some other useful functions include first index, last length, non-standard string literals, regular expressions. So regular expressions look like, just like a regular expression in most languages where you use the R. They didn't reinvent the wheel there. And we say type of. So I guess type of now will show me the type of something. So if I said type of greet, wasn't that a variable I used earlier? There you go, string. So that's useful. Now I know as well that I can use type of to figure out what the type is of something. And here's the classic regular expression match type thing you would do. We can say, oh, that probably won't work on an interpreter. I'd have to play around with it a little bit. But when the capture doesn't match, it contains nothing. Here's our examples. Okay, so yeah, regular expression stuff looks pretty fun. I guess dates. Oh, so in order to use something in Julia, you say using. So that looks interesting. So we'll go here and we'll say using dates. And then next step, we can say D is equal to date. Well, that's definitely, I think, pretty dang simple, right? Like you just say D equals, and if we make the date, let's do this, 2022, and we'll say 7:05. There we go. So we can see that very easy way to create dates. And if we say type of D, there we go, date. So not bad. I'm liking Julia here. And what else can we do? Version number literals. So version numbers can be easily expressed with non-standard strings. Huh, that's interesting that there's a special type called version number. Wow, I like this. I remember earlier in my career I had to create version numbers, and it's kind of an annoying thing to deal with. So, wow, that's very interesting that they would actually do that. I like that. Version number objects can be converted to compare two or more versions. Wow, this is really, I have to admit, this is pretty cool. I guess you would say version number. I'm curious to try this out actually. So version number. Oh, okay. Thanks. I wish they would have put that into the example, but version number. Wow, this is cool. That alone might be one reason for me to use the Julia language. Now I'm seeing some use cases because the version number is something I just happen to deal with all the time for all kinds of projects I'm on. And I like that I could say, let's try this out. So we'll say 1 is equal to that. And then we'll say 2. And then we'll say, let's see if this will compare. 1.2.4. 1 is equal to 2. No. 1 is greater than 2. No. 1 is less than 2. There we go. That's correct. Wow, I like this. I could see myself writing a nice little Julia script to deal with version numbers. I don't even know if Python has, I'm almost certain it doesn't have this built into a language. So congrats to whoever built that into Julia. That's actually a really, really cool feature here. Raw string literals. Okay, so we got through basically strings here, which is a pretty good place to stop, I think. And I guess maybe the last thing I could do is just build like a little Julia script that handles the version numbers, since I got excited about that. So we say, we'll say touch versions.jl, and then I'm going to say this. We'll say version number here. And we'll say one is this. And then we'll say two is this. Or we could do this. We could say first version, like that. And then we could say second version. And we can just say basically prints. Actually, look at how they do the comparison here. Let's see if I can do something. Where's a loop? Do they have a loop here? Control flow. We haven't gotten there yet, but basically, if. Well, let's. I'll cover that in a coming week. I'm gonna stick with strings here. I'm just gonna keep it simple. I'm just gonna say prints first version is greater than second, or is less than second version. And let's see what happens if I just say Julia versions true. Okay, that's good enough. And I'll go ahead and commit this. Git status, git add versions, and actually let's put what I'm going to do next week. So let's see. We'll say ideas for next week, and we don't. We say covered on July 5th. We'll say was strings, basically strings and numbers. Cover on July 12th would be probably next up. We would do functions. There we go. So let's add this to our commit. And we'll say git commit, adding Julia versions code. There we go. All right. So I definitely learned some cool stuff about Julia. I'm loving the versions thing here. And next week we'll cover functions in Julia. So there's some stuff that's starting to get interesting to me in Julia. I always like learning something that, especially if it solves a problem that I've had in the past. And versions are definitely just annoying to deal with, and the fact that they wrote a library is very tempting for me to play around with some code around that. All right, well, see everybody next week to cover functions.